So what exactly is friction? Friction is a non-conservative force, which means it doesn't store energy, but rather it loses energy through heat or sound. It is commonly defined as the resistance that one surface or object encounters when moving over another. So why is friction so important? Well, without friction, we wouldn't be able to stand, we wouldn't be able to walk, and everything around us would continually slide. Have you ever slipped on a patch of black ice? Now imagine the entire world being just as slippery, even more so, and then trying to walk to school. That's why friction's important. Here is an easy physics demonstration of how friction works. Simply slide a large brick across the tabletop. After a little bit, you should notice that the brick comes to a complete halt. This is because your applied force isn't enough to overcome the frictional force that is acting in the opposite direction as your applied force. So, say you decide you want to move this box of things across the floor, but it looks really heavy and you're not sure if you can move it. To begin, there's already forces acting on the box even before you've laid a hand on it. There's normal force, which in this case, because the ground is level, is equal to the mass times gravity. The weight of the box, which is mass times gravity, roots the box into the ground. It's a force that points downward. The normal force acts as an opposing force, which actually pushes up. So in this case, the normal force is equal and opposite to the weight of the box. Now say you want to try pushing that box across the floor. Well, there's two types of friction. There's static friction, and then there's kinetic friction. Static friction is equal to the normal force times the coefficient of static friction. The coefficient of static friction is usually less than 1. Another way to state this equation is the coefficient of static friction times mass times gravity. In order for the box to move, you must first overcome the static frictional force. Once you've overcome that with your applied force, kinetic friction will be working in the opposite direction as your applied force. The equation for kinetic friction is almost the same as the equation for the static friction. Kinetic friction is equal to the coefficient of kinetic friction times the normal force, or the coefficient of kinetic friction times mass times gravity. Now consider a different experiment where the brick is on a plank of wood on an angle. It remains stationary. This is because of static frictional force. When the brick is on an incline, again it has two forces acting on it in the y direction, both the normal force and the weight, except in this instance, because it's on an angle, on the plane, the normal force is equal to mg times the cosine of theta. There are now two forces acting in the x direction. There's mg sine theta, which acts in the positive direction, and the static frictional force, which works in the opposite x direction. Together, the net force of the equation must equal 0 in order to remain at rest. If the net force does not equal 0, then the brick will either move up or slide down. So that's the basics of friction. Be sure to thank it the next time you go for a walk, or you might just end up like this.